So, of course, we're not stopping there. We've got more costs. We've got more costs that we need to define, and eventually we're going to be graphing, right? So the first one that we're going to define is our average total cost. Abbreviated as ATC, sometimes, very rarely, but sometimes abbreviated as just AC. Average cost. Average total cost. They mean the same. If you read or hear something talk about average cost, it's the same dang thing as average total cost. Okay? And anytime we take an average in this class, we're going to take that thing after the term average, right? The thing that it's modifying, and we're going to divide that by the quantity, right? So our average total cost is going to equal our total cost divided by our quantity here. We are going to have another average, this one for our variable cost, AFC is equal to our variable costs divided by our Q. Or sorry, that's fixed cost, AVC. I'm too much ahead of myself in my own head. Average variable cost is the variable cost divided by the quantity. As I just alluded to, we've got an average fixed cost, not court cost. AFC is equal to FC over Q. All right, quick little math aside here for us. So we have this identity that we talked about at the end of the last video and the end of the 7.3 costs in the short run section, right? The end of that slide. We had this identity, which was our total costs are equal to our variable cost plus our fixed cost, right? And so if we divide both sides by Q, which we're totally allowed to do, it's within the rights that we have in doing algebra, we end up with total cost over Q over here is equal to variable cost over Q plus fixed cost over Q, because anytime you divide two terms that are plus or minus by each other by a single term, you can just do this loop-de-loop kind of situation, right, where you do this division and then you plus it with this division, right? So that's all I'm doing here in this step. And now you can recognize this is our average total cost, right? Total cost divided by Q. This is our average fixed cost, and this last one, or sorry, I keep doing that. This is our average variable cost. And then this last one over here is our average fixed cost. And so we have another identity which states that the average total cost is nothing more than the average variable cost plus the average fixed cost. Now, why are we bringing this up? Well, we're bringing this up because when we are going to be graphing this later, part of how you graph the curves has to do with this identity. And so we're going to come back to this in a second, but I just want to tell you that what comes from this, if we subtract the average variable cost from both sides, we end up with an average total cost minus an average variable cost, and that is equal to our average fixed cost. So our average fixed cost is nothing more than the difference between our total and our variable costs. This will come into play in a little bit when we're doing the graphing part. Our last definition for our more costs section is going to be the marginal cost. And let's see. Yes, yellow shows up. Marginal cost. Our marginal cost is the additional cost of producing one more unit of output. Let's write that down. Additional cost of producing one more output unit, right? So we have a MC, marginal cost, is equal to the change in my total cost divided by my change in the quantity. So when we look at these costs, right, if we want to put these costs on a graph, we can do that to look at how total output impacts our total cost. So we have total cost in dollars over here. We have output, which is in units of whatever the heck we're producing over here, right? And we're going to have some sort of gap between the origin and the initial point, right? And that's going to represent our fixed cost. So this example, it's $160. So this line is going to start at 160. And it's going to go up. And then at a certain point, when we hit that diminishing marginal returns, the cost is going to start taking a convex turn up into the unsustainable range, right? Where, you know, up here is, you know, $600–700. So our cost increases gradually until we get to some point, right? So this is probably going to be, if we were looking at the example that we had before with the lumberjacks, right? This would be when the L is equal to, you know, probably 3, right? Or maybe 4. I would say 4. So L around 3 or 4, that's when we start to change. There's an inflection point from a concave line to a convex line, right? I didn't draw it terribly well here, but this part over here is concave. It's more of a hump situation. And then we have an inflection point here, and then it starts to go up, 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 up at an increasing rate. Questions on this particular graph? So we're going to split to another video in a second, and we're going to graph the actual costs, or the averages of the costs.